Hey guys, here we are, chapter 21.5, dealing with hazardous waste. What do we do with the truly toxic stuff? Now, scientists, governments, when we get together and decide what should we do, the sustainable approach is this. Number one, do everything we can to produce less of it. What we do have, reuse and recycle it, use it over and over again, transfer it to different people. In other words, one process might make it as part of it, but then somebody else might need that for what they're doing. Once again, recycle it, reuse it, don't just get rid of it. When we do have it, convert it into less hazardous materials. We'll talk about ways to do that. And things that we can't do this with has to safely be stored, whatever happens to be left. This is a sustainable method that we've come up with, everybody agrees on. Sometimes it's just a matter of making it happen, right? Trying to take care of the nitty-gritty details. Now, hazardous waste does require special handling. We can't just toss it in a normal landfill, or it's got to be dealt with carefully because it's toxic, right? We talked about toxicity levels. These are the things that make people sick, lead to cancer or death, depending on the dose, right? So really what we want to try and do is follow some of the best practices. Number one, try and use less, right? Let's find substitutes for the toxic or hazardous materials. A long time ago, we used to use mercury on beaver hides to make felt. Well, we've long since learned how to make felt without having to use mercury. Sometimes it's research coming up with different substances. If they can be used, different substances should be used. We do want to reuse or recycle the hazardous material that's in an industrial process. Because when it's all said and done, chemical company A has this hazardous waste material, but company C over there might need that chemical for part of what they're doing. So instead of ordering it from somewhere else that's just making it, let's use what's already out here. Kind of look at it as raw materials. When one company's done with it, can we sell it or provide it to another company that's going to need it? Let's keep it in use instead of out there in the wild, if you will. We need to have some kind of clearinghouse, if you will, to exchange these raw materials. Somebody that has a middleman, if you will. We produce it, but we don't really know who all's out there using it. It's not their industry. Need to have somebody that really does. Hey, yeah, you have that, I have a buyer over here. We just need to make sure that this stuff is used if it's out there before just this company tossing it away when other people are making it for this company over here. Anyway, we get the idea. We want to produce less of it. This is just changing our industrial processes, like I talked about the mercury and the beaver hide, right? We need to find ways to eliminate hazardous waste production. Can we change the way we're doing things? Just because it's what we've always done doesn't mean it's the best way to go about doing it. And whatever does get produced, we can't do anything, recycle, reuse best we can. Then it's a matter of converting it to less hazardous or into a non-hazardous substance. Different ways we can go about it, and we'll talk about some of these. Natural decomposition. Most things decompose. We do have those persistent chemicals, but most things tend to break down over time. Entropy, right? Goes from higher order to lower order. Incineration, we can burn it. By burning it up, this gets rid of the waste. Now, sometimes it might put it up in the air, but sometimes the burning is decomposition. It's causing it to break down quicker. Thermal treatments, maybe we're not going to burn it to the point of flaming it, but by heating it up, once again, it's kind of going back to this natural decomposition. We're just speeding it up. By heating it up, it may break apart quicker. Chemical, physical, and biological treatment. Chemical, we can just add another chemical to it. Chemical reaction turns it into new substances, which can be less hazardous. There's some physical means we'll talk about, which might just mean storing it, if you will. Biological treatment. There are some forms of bacteria, other organisms that might break it down. Even plants, putting on plants, letting plants begin this breakdown process. And it can sometimes just be diluted in air or water. In these concentrations, it's dangerous, but in this concentration, it's not. So toxicity sometimes has to do with concentration, how concentrated it is, in a matter of doses. One of the things we can do, just a physical means, if you will, is put it in perpetual storage. We're going to put it somewhere and leave it there, lock and throw away the key, right? Now, landfills are some landfills have areas that deal with the hazardous waste, but it's got to be a hazardous waste treatment, not just your normal local landfill where we chunk it, especially not a open dump. We also have what we call underground injection wells. We drill a really deep well, and then we'll put something, encase it, drop it down in as well, which will be really deep down in the earth below our aquifers, and then seal it up. So it's kind of down there, a half mile away from nobody's going to get to it without actually trying. We have surface impoundments. Now, once again, we put it in some sort of tank up on the surface, and we're letting nature do its thing. We're letting the water evaporate away and get it down into a smaller amount. Now, we may wind up with a tiny bit we have to stick in that injection well, but once again, surface impoundments, and also underground salt formations. Some of these salt, like where we get salt mines, but not the ones up high that we access. There's some salt mines, salt deposits really deep down in the earth, and we can inject these down into the salts. The salts will absorb it up, and it's down there once again, a half mile down deep in the earth, away from human presence. Once again, we just have to pick these sites carefully because we want to put it somewhere where it's going to leach into, a water supply. Those are just some of the physical ways that we can take care of hazardous waste. We have a case study here on e-waste. Now, we've talked about e-waste, the problem of the metals that may be in it, other chemicals, toxicity, and then when it comes to trying to extract those things. Putting a picture up here of a little girl in Dhaka working in an e-waste area. They're trying to grab these electric parts, or pulling out the motherboards, the little bits from it. Well, once they have some of the raw parts, if you will, they have to extract the lead that's in there and the soldering. They have to try and extract the gold that's in it, some of the rare earth metals, and a lot of times they're using hazardous chemicals to do this. They'll use acid to leach out the gold, maybe the cyanide salts, things that we've looked at in mining practices. They're mining the trash, if you will, but then they still have to extract these. So they're melting down some of the things to extract out the gold, the lead, the copper, the different things that are needed, and then some of these rare earth metals. Then they have these leftover parts. So they've done some pretty hazardous type stuff. A lot of the people working these are exposed to these toxic chemicals and problems. Then they have these leftover bits. And then a lot of times these leftover bits, they're just then burned, which can add to it up in the air, or just dumped into rivers or somewhere else. The long-term solution to this is the cradle to the cradle solution. Our electronics should not be going into landfills. They should be going into recycling centers. The companies that make them need to be able to take them back and pull this stuff out back themselves. They need to see this as raw materials that need to come back to them. But it's a shift in how we do things. Instead of the idea of cradle to grave, we need to have the idea of cradle to cradle. Let's reuse, reuse, reuse. We can collect it and then detoxify it, right? Now, physical methods, we'll look at some physical methods, chemical methods, making a chemical reaction, bioremediation, allowing biology, animals, organisms of some kind to break it down. Phytoremediation, this is plants, phyto. They're using the sunlight to absorb and then break down some of these elements. And we have plasma gasification. This is incinerating with a plasma arc torch. Now with this, let's kind of look at some pros and cons of this plasma arc torch. Putting a picture of one up here that you can kind of look at. It's just this really high electricity intense heat, like lightning, if you will. Plasma, the fourth element, solid, liquid, gas. Plasma, this is what lightning is made of. Our stars are largely plasma. Very high heat. The advantages, it produces a mixture of carbon monoxide and hydrogen that can be used as a fuel. So as it is incinerating this stuff at incredibly high heat, really with electricity, it does create carbon monoxide and it creates hydrogen. The hydrogen can be captured. We can use this as fuel. They're mobile. We can move them from site to site, which is a very benefit. It doesn't have to be like our incinerators. It's a very big, large, complicated process. These are not. They're mobile. You can take them from here to there, use it in this site, anyway. And it produces no toxic ash. There's really nothing left from this plasma arc. This is one way that we can deal with some hazardous materials. The disadvantages, it's expensive. It takes an awful lot of electricity power to run the plasma arc. It does produce carbon dioxide and carbon monoxide. And carbon monoxide is a poison in high enough concentrations. It does release some particulates as well as chlorine gas. Sort of depends on what the materials are, but chlorine gas is something that gets vaporized from it as well. And it can vaporize and just release toxic metals. If there's mercury down in the site that we're doing, if there's lead in it or any other radioactive elements that may be processed, these can be vaporized into the air. And once again, pros and cons to both sides. Plasma arc can be very good, but it can't be used really for everything. Burial and land or long-term storage. This is the most commonly used today. We tend to get our hazardous materials. When we get it, we try to bury them in a safe location. It's fairly low cost. You dig a pit, you stick it in it. Now it's a little bit more complicated than that. We try and line the pit, seal it off, all these things, or it's once again that deep well disposal. Drilling a really deep well, half mile or so, depending, seal everything up in a concrete casket, drop it down there, fill it back up, and it's taken care of. It's not going to leak out, at least not for a very, very long time. Surface impoundments. This is where we're sort of putting it in a pond up here. Not only is it not going to be an open pond, we'll put in some sort of open tank so that the water cycle can do its part, right? Can evaporate everything out away from it till we're left with just the truly toxic bits that we can then try and come up with one of these other methods. So we can use lined ponds, pits, or lagoons. They need to be lined so the stuff doesn't leak down into our water supply. Of course, the dangers there. Anything can wind up leaking out, storms, problems. And then our secure hazardous waste landfills. So this is a special landfill, if you will. It only works in the hazardous waste, but these are obviously expensive. They have to be manned, they have to be protected. We have to have special things put in place to make sure none of the stuff is actually leaking out, getting into the groundwater. When we talk about these deep well disposals, so it's just a very simple graphic of it back here, but advantages of them. If the sites are chosen carefully, away from water supplies, below aquifers, not near tectonic plate, all this stuff, the sites can be very safe. Waste can even often be retrieved. We know exactly where they are. So it's the kind of thing we can go back if need be and remove them. We learn something else, we find, they can be pulled out. And they're fairly low cost. Once again, it's just drilling the pit, knowing the location, and it's not like just one, we could put multiples in the same area. Disadvantages. Obviously, these well casings could crack, leak. If we have any kind of tectonic plate action on with fracking, we get an earthquake we weren't planning on. It does emit CO2 because we're digging down into the ground. Anytime we do that, we're releasing carbon dioxide, which is trapped in there. And it's an output approach. It's the idea, hey, you make it, we'll take care of it, give it to us. Tends to encourage waste production. We really want ideas out there that don't encourage the production, but are trying to minimize it. So let's find ways to not make the substance. That's the best way to go. Now, surface impoundments. We're just gonna put it up here on the land, right? In some kind of lagoon, pit, what have you. Again, advantages, very low cost. It's up here on the ground. We dump it into it. Very easy to do, if you will. The waste, once again, can be retrieved. Really, ooh, company C over there actually needs this. We can retrieve it and sell it to that company or get it to them. We can store waste indefinitely with kind of double liners. We need to line it with, we're not just lining it with basic plastic, but with several liners. They can last a very long time. Once again, theoretically, indefinitely, we can keep this waste in this area, once again, in case it's possibly needed, and to keep it out of the water supply wherever else. The disadvantages. Well, anything is going to leak eventually. You know, it might be good for 100 years, 200 years, but eventually things begin to break apart and things leak out. And if it's out there in the open, we have a big storm, there's rain, it can overflow, right? Something can happen we're just not planning on. If this stuff is out there, the water cycle's doing its part, well, any volatile organic compounds, these VOCs, are going to evaporate as well. Like you put alcohol out on the table and it evaporates up. It's not the water evaporating, the alcohol itself evaporates. Some things vaporize easier than others. Some things, if it's solids, they don't evaporate out. But anyway, not the only thing evaporating isn't necessarily water. And once again, it's an output approach. Hey, we can store that waste for you here. You pay us a certain amount and we'll store it for you. It's still this output approach. It's not trying to really solve the problem. And when we talk about these wastes, I mean, this is kind of what it looks like. We just have an underground lined area, pit, that we go into and we store all the waste. Once it's full, you know, we can't fit anymore, then we can seal it over with cement, lay it down and put clay over the top. And we have some ventilations in there for various things, but this is the idea. They're fairly expensive on one end, you know, but we're having to charge the companies for it. It's just not really a permanent solution, if you will. Well, what do you and I do, right? What's our part in all this? Oh, well, that's the businesses, they're doing it. It's industry, they shouldn't do it. Well, some of it comes down to you and me. If we don't buy the products, they won't make them. Or if we say you're using hazardous, some of it does come down to us. You and I, we can avoid using pesticides and other chemicals, or at least keep them in the smallest amounts possible. Once again, if you and I aren't buying it, they're not going to make it. They're going to come up with other solutions if we refuse to buy it. This is back to the 4 R's. Refuse. That's our power. Use less harmful substances instead of more harmful substances. When it comes to commercial household cleaners, you know, using vinegar and baking soda where possible. Sometimes that's not always there. But when you go to buy cleaning supplies, they are green. They'll literally say, this is a green product. It's using non-harmful chemicals. Use the less harmful chemicals whenever possible, and only use the really harsh chemicals when absolutely necessary. Once again, refuse as much as possible and reuse what you have. And when it comes down to it, don't throw the hazardous stuff away. Fluorescent light bulbs, any of the many compact fluorescent light bulbs, do not toss these in the trash can. They have mercury vapor in them. They need to go to hazardous waste site. Some of them contain mercury. All of our electronics, paint thinner, all of these things are hazardous and they need to go to hazardous waste sites. But these are just some of the things that you and I can do to make sure that we're doing our part to minimize the hazardous materials out there in the world. Now, in 1976, the Resource Conservation and Recovery Act, the RCRA, set standards to give permits about hazardous waste. You know, who can use it and who can't. We need it for this industry. You have to have a permit and agreement to do it. But unfortunately, this only covers about 5% of the hazardous waste in the United States. And this was that cradle to grave approach. You have a permit to use it and even, you know, to potentially then dispose of it. It just doesn't cover a whole lot. In 1980, the Comprehensive Environmental Compensation and Liability Act was formed. CERCLA, better known as the Superfund Act. Go all the way back to the first 9 weeks. And this was our first 9 weeks project in my class. You had to research a Superfund site. This was from the Comprehensive Environmental Compensation and Liability Act. In 2016, there were 1,223 Superfund sites. 391 of them had been cleaned up. You know, we identified them back in the 80s. By 2016, around 400 had been cleaned up. The pace of cleaning up Superfund sites has actually slowed down because the funding was discontinued. The companies that produce the hazardous materials, they used to have a tax on them. they had to pay a tax because they used these. That tax money was used to help clean up Superfund sites after they're left over. That law kind of got repealed, or at least a part of it, and we no longer tax the companies. So the only way that Superfund sites get cleaned up is it's taxpayers' dollars. Just comes out of tax. There's not enough funding for it. Not as many sites are being cleaned up. The pace of cleaning it up has slowed down remarkably. Now, there are laws on the book that really encourage the cleanup of brownfields. Brownfields are abandoned industrial sites, because this is the problem with some of these things. They get flagged, hey, you're doing this, you've got a problem, now you have to clean it up, and the company declares bankruptcy. We can't do it. It's a $10 million problem. We only have $1 million in assets. We have to declare bankruptcy, and it's just there. These are our Superfund sites, are also known as brownfields. They're just left, and there's not much we can really do about them. So what do? Should we tax the companies, or should it be the taxpayers' burden? It's a question, and right now it's left to the taxpayers, not the companies that are producing it. Guys, that wraps us up for hazardous waste, what to do with it, some of the ideas that are out there. Come back next time and we'll talk about a low waste economy. Kind of the goal, right? Take care.